Okay, greetings. So welcome to today's class. So a quick recap of what we did in the previous class. We looked at the operation of a typical 4-stroke internal combustion engine. We learned what the 4 strokes were and what were the characteristics, and we also learned a few definitions, right, associated with engines. And we stopped with a brief introduction to 2-stroke engines. That's what I'm going to build on today. So, as we have already learnt, a 2-stroke engine is one in which one operating cycle of the engine is completed in 2 strokes of the piston, okay, and so that corresponds to one complete revolution of the crankshaft. And if we look at this schematic of a 2-stroke engine, we can immediately observe that as opposed to a 4-stroke engine, in a 2-stroke engine, we do not have intake and exhaust valves, and we also do not have the actuation mechanism for the intake and exhaust valves in the form of camshafts, timing belts and so on. Okay. So, those are absent. So, as a result, we can observe that the cylinder head is pretty much thin when compared to a 4-stroke engine, right. So, that saves a lot of mass, right, in a 2-stroke engine. So, we do not have those assemblies, right, as far as intake and exhaust valves are concerned. So, how are air, fuel taken into the cylinder and exhaust gas removed from the cylinder in a 2-stroke engine? These functions are performed by what are called as the intake ports and exhaust ports respectively. Okay. So, we shall shortly see how the 2-stroke engine works. So, let me consider a 2-stroke spark ignition engine to begin with. As we know already, in a spark ignition engine, we have a spark plug which ignites the fuel air mixture that results in combustion. So, we have an intake port, we have an exhaust port, we also have what is called as a transfer port. Okay. So, in a 2-stroke engine, we can observe that the piston divides the entire engine assembly into 2 broad regions, right. So, one is the region below this, which in general, like we call as a crankcase region, right. So, because most of it is in the crankcase, right, and another region above this, which is the combustion chamber. So, what happens in a 2-stroke engine? Let us go and look at simple schematics which explain the various operations that take place in a typical cycle of a 2-stroke spark ignition engine. As we can readily observe from this schematic, we can see that the piston itself opens and closes the ports. Now, there is no separate valve assembly for opening and closing the the restrictions through which air or fuel air mixture comes in and exhaust gases go out, right. The piston itself covers and uncovers these various ports. So, let us look at what happens. So, this stroke, the first stroke that we are going to look at is what is called as the upward stroke of the piston. So, what is this upward stroke? The upward stroke of the piston, as the name indicates, is what happens when the piston is going from the bottom dead center to the top dead center. Okay. So, let us say somewhere here is my bottom dead center and somewhere here is my top dead center. So, the piston is moving upwards from the bottom dead center to the top dead center. So, let us look at what are all the processes that happen when the piston does so. When the piston moves from the bottom dead center to the top dead center, it starts pushing out the burnt exhaust gases that have accumulated in the combustion chamber from the previous cycle. So, you can immediately see that the exhaust gases start being pushed out, like through the exhaust port. Okay. So, this is the exhaust port. At the same time, when the piston starts moving up, the fresh fuel air mixture which is present in the crankcase, we would see how this comes in, okay, when we look at the downward stroke. So, the fresh fuel air mixture, which is also pressurized, right, it essentially gets transferred to the top part of the above the piston, okay, which is the combustion chamber, through what is called as a transfer port. Okay. So, the fresh fuel air mixture for the next ignition process gets transferred through the transfer port into the combustion chamber, and the piston head is shaped in such a way that the fuel air mixture does not directly go and mix with the exhaust and go out of the exhaust port, right, because that will be resulting in unburned fuel air mixture in the exhaust, which is not beneficial, and we do not want the exhaust also to come and mix with the fresh fuel air mixture, because that is going to inhibit proper combustion of the fresh fuel air mixture, right. So, the shape of the piston head becomes important. So, the fresh fuel air mixture starts to come into the combustion chamber, and as the piston goes up, what is going to happen? We are going to observe that it is going to essentially close the exhaust port and the transfer port after some time. Then what will happen? The fresh fuel air mixture gets compressed. Correct. So, whatever has come in through the transfer port, through the initial part of the upstroke, that starts getting compressed once the exhaust port and the transfer port are covered by the piston. So, the fuel air mixture gets compressed, but you can immediately observe that the inlet port at some point is opened. So, what will happen? Through the inlet port, the fuel air mixture for the next cycle starts coming into the crankcase, because we know that this is the this is the crankcase, right. The fuel air mixture for the next cycle starts coming into the crankcase. So, when the piston reaches close to the top dead center, what is going to happen is that this fuel air mixture is compressed, and then we are going to have a spark, right, from the spark plug, and the fuel air mixture gets ignited. So, now let us come to the downstroke.
Sir.
Yes, please.
Sir, what causes the piston to go up in the first place when there is no spark ignition?
Before combustion, we have to crank the engine. You need to provide the mechanical effort to make the piston go upwards and downwards.
No, but in a real car?
In a real car, the energy or in a real automobile, the energy which is released is consumed for this process. Okay, we are going to a part of the energy is used for this upstroke. In fact, in a 4-stroke engine, we observe that there is only one power stroke, right. So, that is the during that stroke, a significant amount of energy is transferred to the piston, and a part of that is going to be used for the other 3 strokes.
By energy, do you mean inertia of that crankcase?
No, energy, basically it is essentially the energy which is transmitted via the burning combustion of the fuel, that is converted to thermal energy, right. The thermal energy is converted to kinetic energy. A part of that is going to be used for moving the piston in the other 3 strokes, in addition to other aspects which we will see when we do the analysis. Okay. So, coming to the downstroke, we can immediately observe that once the fuel air mixture gets ignited by the spark plug, we are going to have combustion, right. So, we are going to have lot of thermal energy being created from the chemical energy of the fuel, and we are going to have high pressures and temperatures in the combustion chamber. That is going to push the piston down. When the piston is pushed, what is going to happen? Let us say at some point of time, it has come to this level, right, it is moving down. When the piston is pushed, it will close the inlet port, And since fuel air mixture has already been taken for the next cycle through the inlet port during the upstroke, that fuel air mixture will get compressed, right, in the crankcase. So, the compression of the fuel air mixture for the next cycle happens in the crankcase. And as the piston keeps on moving down, the exhaust port is open, so that the exhaust gases from this cycle escapes to the exhaust system from the cylinder, and then the transfer port is open, so that the compressed fuel air mixture in the crankcase is then transferred through the transfer port up to the combustion chamber. So, all these steps keep on repeating, okay, one after the other. So, we can immediately see that many of these steps happen simultaneously in a two-stroke engine. What do I mean by this? The process of introducing fresh fuel air mixture into the combustion chamber for the next cycle happens through a part of the downward stroke towards the end, and also the initial phase of the upward stroke. Okay. The exhaust of the burned gases also happens during the later part of the downward stroke and also through the initial part of the upward stroke. So, you can see that many of these strokes happen, many of these operations, right, happen at various phases of these two strokes. Okay. So, this is essentially, this process is what is called as crankcase scavenging. Okay. So, the reason being that the fresh fuel air mixture for the next cycle is scavenged or taken from the crankcase. Okay. So, for the next upcoming cycle, the charge is first introduced in the crankcase, pressurized, then taken from this. So, this is how a typical two-stroke engine operates. So, now a few critical points as far as a two-stroke engine's operation is concerned, right. To summarize, once again, there are only two strokes, an upward stroke and a downward stroke, and all the processes of like compression, intake, exhaust, transfer, are distributed between these two strokes. Okay. So, you can immediately observe that there are a few differences between the way a 4-stroke engine works and a 2-stroke engine works. Now, if I have a comparable 4-stroke engine and a 2-stroke engine, like with things being the same, and they are operated under similar conditions, like similar loads, similar speeds and so on. When you compare it to a 4-stroke engine, a 2-stroke engine will have twice the number of power strokes, would it not? Then theoretically I should get twice the power output from a 2-stroke engine. Do you agree? Right, because everything remains the same, right, you keep everything else the same, theoretically we should get twice the power output for the same operating conditions, due to the simple fact that a 2-stroke engine has 1 power stroke per revolution of the crankshaft. But that is something which rarely happens in practice. Of course, the flip side is that the 2-stroke engine also will have twice the fuel consumption, because fuel is also taken that many times, right, more. Okay. So, we will come to that shortly. So, why do we not get twice the power output even if you have comparable 2-stroke and 4-stroke engines? There are multiple reasons for that. The first reason, foremost reason, is that if you look at how a 2-stroke engine operates during the downstroke, you have high pressure gases, right, that are products of combustion, and they are going to push the piston down, and the exhaust port is opened when the piston starts to travel during the downstroke. So, even before the downstroke is completed, what do I mean by that? The piston moves from the top dead center to the bottom dead center, the exhaust port is open. So, the expansion process itself does not take place over a complete stroke of the piston. Okay, what do I mean by expansion? Effective expansion, right? I could have converted more thermal energy into kinetic energy had I not opened the exhaust port earlier. In a 4-stroke engine, we wait, right? We wait till the piston reaches the bottom dead center, then on the way up, when it reaches the bottom dead center, we open the exhaust valve and the exhaust gases are pushed out, but not in a 2-stroke engine. So, the first limitation which prevents this lack of twice the power output from a typical 4-stroke engine is the reduced effective expansion stroke. Okay. So, that is something which we need to remember. Can there be some other effects in a 2-stroke engine? Yes, there are, right. So, 2-stroke engines also can, even though we design it very carefully, the way it operates, we can also have what is called as exhaust gas dilution. What do I mean by this? Because the fresh charge for the next cycle and the exhaust gas from the previous cycle are present in the same chamber for an extended period of time, right, during the downstroke and part of the upstroke. So, there is a good chance that even though we may design the piston head and the ports and the other assemblies carefully, there is still a good chance for them to mix together, and exhaust gas dilution is the term given to the phenomena by which exhaust gases mix with the fresh fuel air mixture, and that is going to reduce the chances of effective combustion, right. So, even combustion, please remember, it is the process of converting chemical energy to thermal energy, it has its own efficiency. So, if I mix with exhaust gases, the efficiency of that energy conversion process also will go down, right. So, that is another limitation, okay. And even if we are able to overcome these issues, please note that since one power stroke takes place every revolution, by and large 2-stroke engines, their speeds are limited, because otherwise the thermal load will increase. Imagine, like if you keep everything the same and you are burning fuel once in every revolution, right, it is going to become extremely hot, is it not? So, how do you ensure the thermal loads are reasonable? You reduce the number of power strokes. If we reduce the number of power strokes, what we are effectively doing? We are reducing the design speeds themselves, right. So, the 2-stroke engines are relatively designed to be lower speed engines because of the restriction on the thermal loads that come in. Now, what do I mean by thermal loads? The heat energy that the engine needs to dissipate, right, it is going to get very hot, okay. So, we can immediately observe that these effects are going to lead to lower efficiency, and more, we will introduce this term later, what is called as specific fuel consumption. So, what do I mean by specific fuel consumption? It is the mass of fuel consumed per unit power delivered by the engine. We will define it carefully when we come to engine performance, but when you compare it to 4-stroke engines, like 2-stroke engines are going to have lower efficiency and more specific fuel consumption. That means like lower mileage, right. So, more specific fuel consumption means like the mileage that you get in terms of kilometers per liter of fuel, right, that is going to drop, okay. So, lower mileage, okay, in terms of kilometers per liter or miles per liter, right, depending on the units that we use, fine. So, those are all typical limitations of 2-stroke engines. Now, there is also another issue which comes in two-stroke engines, as you can see, the crankcase is not used as a sump for lubricating oil. There is no separate channel for circulating the what to say coolant, the lubricating oil and so on. So, as we would have seen from experience, right, if we have a two-wheeler or an auto rickshaw, with a two-stroke engine, when we go to a fuel station, the engine oil is mixed with petrol. So, the lubricant is mixed with the fuel and burns along with the fuel, and the lubricant is different from fuel in chemical composition. So, that is going to bring in its own emission issues, right. So, it is going to affect the performance of the two-stroke engine, and more importantly, in the current scenario, it is going to result in increased tailpipe emission, right. So, that is one significant issue with two-stroke engines. So, these are all some limitations why two-stroke engines are also, we can slowly observe that on roads, like we do not have so many two-stroke engines today, right. So, they are slowly being phased out. But what are the advantages? Obviously, they have advantages, right. So, the main advantages are, although it does not give you twice the power, right, for twice the fuel consumption with everything remaining the same, still the power to mass ratio, or what is called power to weight ratio of two-stroke engines is higher than four-stroke engines. Multiple reasons for that. Of course, you will get more than what a four-stroke engine delivers for the same configuration, but as we already seen, even the initial mass of a two-stroke engine is small. Why? Because there is no, the cylinder head is very thin, there are no valve assemblies, no camshafts, right, no timing gears or timing bells and other mechanisms, right, for that, okay, no lubrication, separate lubrication circuits, right, engine oil pumps and so on, right. So, all those are not present. So, if you take the engine as a unit, so the power to weight ratio or power to mass ratio is higher in a two-stroke engine. That means that if you look at it from the other perspective, two-stroke engines can be made compact for the same power requirement, right. If you want, let us say X kilowatt of power output from a two-stroke engine and a four-stroke engine, two-stroke engines are going to be more compact and lighter if you compare them, right. So, that is a good advantage. And another aspect which contributes to this reduced mass is that since in a two-stroke engine you have one power stroke per revolution, the turning moment, what do I mean by turning moment? The torque, okay, which is available at the output of the crankshaft is more uniform, and this implies a lighter flywheel, because we are going to have energy conversion every revolution of the crankshaft, right. So, why do we use a flywheel? We want to dampen out the torque fluctuations, but the torque fluctuations themselves are smaller in a two-stroke engine. So, consequently, we go for a lighter flywheel. Of course, one more, these are some good points about two-stroke engines. One more limitation is that since one power stroke or one combustion happens in every revolution of the crankshaft, right. So, the wear and tear and the lubrication requirements are also higher, okay. So, wear and tear of the engine and lubrication requirements are higher in a two-stroke engine. So, where do we use two-stroke engines? Typical application domains, typically used where the application domains of two-stroke engines traditionally has been where cost, I would say low cost, right? Compactness, okay, less mass, okay, these are important, okay, applications where we need to reduce these attributes, right, or meet these attributes. That is where the two-stroke engine is traditionally used. Of course, in road vehicle application, now the main reason why two-stroke engines are their presence is reducing is due to emission. All right, so that's a pressing concern. Okay, that's a broad overview of two-stroke engines.